Hi guys, welcome back to the channel. In today's video I'm going to be talking about how to connect solar charge controllers to your panels. The right way to connect them to different kinds of solar charge controllers, because we have primarily three types of solar charge controllers. We have the PWM charge controller, we have the MPPT, then as well we have the hybrid inverter charge controller. There are hybrid inverters that have charge controllers inside of them. We start with the PWM controller. Now for PWM controller, one thing you need to understand is that whenever you are connecting solar panels to PWM controllers, you must make sure as much as possible, try to make sure the connection is parallel connection. Try to avoid series connection of your solar panels. I've already talked about parallel and series connection in my previous videos. You can check that out. Now, for solar panels, for instance, you have this amount of panels. We have 3 panels. Now, solar panels, they have specifications that you need to take note of. The important specifications are the voltage and the current. You have, for instance, a regular solar panel of 12 volts. This is a 12 volt panel. This is a 12 volt panel. Now, 12 volt panels, you can have up to maybe 15 volts on the as the VOC, but the nominal voltage is 12 volts. Now, let's use 12 to avoid confusion. Now, and each of these 12 volts, let's say the current rating is about 3 amps. 3 amps, 3 amps, 3 amps. Now, what happens when you connect these solar panels to a PWM controller? For instance, we have one battery. This is your battery of 12 volts, a 12 volt battery, one battery. Now, what happens is that if you connect them, there are 2 ways of connecting solar panels, or 3 ways. We have series connection, we have parallel connection, and we have power series connection, which is mixture of parallel and series connection. Now, I said for PWM controllers, you need to make sure that the connection is mostly parallel. Avoid series connection, because one thing about parallel connection is that it makes the voltage of whatever system you're connecting to be the same. When you connect systems in parallel, the voltage does not change. The voltage remains the same. But what changes is the current. Now, this parallel connection. This is your positive, negative, positive, negative, positive, negative. Now all the positive will be connected together from this to this to this, and all the negative connected together. Then the output, which is what we have here, positive and negative, will be connected to your controller like this. So when you do this connection, what will happen is that we have 12 volts at the output, 12 volts, but the current rating, which is 3 and 3, they will add up to give you 9 amps. 12 volts and 9 amps. So this is what will go into your battery to charge your battery from the controller. For PWM controllers, you need to make sure that the voltage of the battery is equal to the voltage of the panel connection. If the voltage of the panel connection is more than the voltage of the battery, what happens is that the controller will only take the voltage that it needs. The excess voltage will be counted as losses. For you to be able to maximize the use of your PWM controller, you need to make sure that the voltage of the connection for your panels is equal to the voltage of the battery. If you have a 24 volt battery, for instance, we have 2 12 volt batteries connected together to get a 24 volts, something like this. What happens when you have 3 panels? You know that 3 panels won't be enough. You should be looking at 4 panels, or from 4 to 6 panels. Now, if you have 4 panels, 1, 2, 3, 4. If you have 4 panels, and this is a 24 volt system right now, this 12, this 12, but the output here is 24 volts. 24 volts as the output. Now you need to make sure you use a bigger panel. These panels are 12 volt panels. You need to go for 24 volt panels, because when you go for 24 volt panels and you connect them in parallel, you're also going to be able to match the voltage of the battery connection, which is 24 volts. So if you have these as 24, 24, 24, 24, and you connect all of them in parallel as well to the PWM charge controller, what happens is that, let's say this is the output connected to the PWM. What happens? The PWM give you 24 volts to the battery to charge the battery. Now, if this one is, let's say for a 24 volt system, you have more current, If this one is, let's say, 5 amps, 5 amps, 5 amps, and 5 amps, you add up all the current together, which is 5 plus 5 plus 5 plus 5, that's 20 amps. So we have 20 amps, 24 volts. Then you can no longer use a PWM controller that is below 15 amps. So you should be thinking about using 40 amps or 30 amps and above, because we have 20 amps as maximum current that can be produced from the solar panels. Each charge controller has a current rating and also a voltage rating. There are some charge controllers that accept both 12 volts and 24 volts. It is always written on the nameplate of the solar charge controller. So as much as possible, try to avoid series connection, because what series connection does is that it makes the voltage to be more than what is required, more than what is needed. So that is that for PWM controllers. And one thing you need to know about parallel connection is that when you connect systems in parallel, as the current increases, you need to ensure that the cable size for the wires you are using, the DC cable you are using to transmit the current or the voltage to the battery to charge, you need to make sure that the cable size is big enough to accept whatever current that is entering. But for PWM systems, most times they are mostly small systems, so you don't need to worry much about the how big the cable size is. If you have 9 amps going to your battery, maybe at best 15 amps going to your battery, 20 amps, you can use, let's say, a 6 mm cable for that. You can accept these currents, understand? So for your PWM charge controllers, that's that for PWM. Now let's go to MPPT controllers. Now, MPPT controllers, with MPPT, you have more flexibility. You can connect in parallel, and you can also connect in parallel and series connection. But in MPPT, series connection, a lot of series connections must be avoided at all costs. MPPT controllers, they have higher voltage and current range. You can have up to 20, 30 amps, 40 amps, there's 50 amps, there's 100, there's even 120 amps. Now, for a regular an average MPPT controller of 100 amps, you can have a voltage range that is, let's say, 125 volts PV. Everything, all these specifications are written on the nameplate of the controller for you to see, for you to observe and know what you are doing. Now, if you have 125 volts, it means you can connect your solar panels, you can connect higher wattage solar panels or higher voltage solar panels within this range. You are going to work within this range, this 125 volt PV and 100 amps. Most MPPT controllers, you can have 12 volts, 24 volts, and 48 volts. You can work with both 12 volt systems, for 24 volt systems, and 48 volt systems, provided whatever you are connecting is within the range of this specification, the current and the voltage. Now, if you have 125 volts, let's say it's 120 volts, let's say we have 120 volts, then you'll be looking at 48 volt panels. 48 volt panels from around 400 watts and above, are 48 volt panels. You can have up to 6 solar panels. If you have 6 solar panels, now you are not expected to connect everything in series, because when you connect everything in series, what will happen is that you are increasing the voltage, because series connection increases voltage and makes the current to be the same. The current doesn't change. So if this is a 48 volt panel, or let's say it's 40 volts, to make our calculation easy. If this is 40, this 40, this 40, this 40, this 40, and this 40. If you multiply 40 by 6, that's already 240 volts. So when you connect everything here in series to your MPPT charge controller, it's going to burn the charge controller, because it's above the voltage range that is written here. That is why most times a lot of installers have problems, issues with this kind of connections. Now you would think, okay, because you've been using a hybrid inverter for connection, because hybrid inverters accept this kind of connection. When you want to change, or when there's need for you to change to a controller, and you don't go up there to rewire the connection for the solar panels, you connect it directly to an MPPT controller, you are going to burn the controller. Now this is whooping 240 volts. Your controller cannot accept that. These 100 amps, you have to make use of these amps here. You cannot be having 240 volts and you have this 10, maybe this like 10 amps. You have 10 amps when your controller can accept up to 100 amps for MPPT. So what you do, you make sure you as an installer, you are going to at that point come in to see how you can balance the voltage and currents within what you have here, within these specifications that you have here. This is where parallel and series connection comes in, power series. Now you can either connect two in series, two in series, two in series, then you parallel the outputs, or you connect three in series, three in series, and you parallel the outputs. Anyone can work. So if you connect two in series, you have something like this. These two, connect these two in series, then connect these two in series, then also connect these two in series. When you connect these two in series, you have 40 plus 40, you have 80 volts here. Then you have under 80 volts here. Then you have under 80 volts here. So the system voltage is now 80 volts. Then you can now connect the output of each of these two series connections, because right now when you connect in series, we can see these two solar panels as one. So the output of these two solar panels, you connect them in parallel. So this plus, minus, plus, minus, plus, minus. Connect all the plus together, connect all the minus together. So when you connect everything together now, if this is 10 amps, because this is 40 and 40 volts, to give you 80 volts, we have 10 amps. So by the time you connect in parallel, you'll be having 10 plus 10 plus 10, 30 amps. So you have 80 volts, 30 amps. It's within the safe range here. So you can connect, it means you can even connect up to 12 panels. If you have 12 panels, you can connect TV in series. When you have TV in series, you have 40 times 3, which is 120 volts. Okay, let's assume your controller right now it's 145 volts. Yeah, it's actually 145 volts. So when you connect TV in series, you have 120 volts. If you have 120 volts, it means if you connect three series connection, if you have 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you connect three in series, three in series, three in series, three in series, it means you are going to have 4 parallel connections, 1, 2, 3, 4. So each of these parallel connections, we have 10, 20, 30, 40, that's 40 amps. So you'll be having 40 amps. Then when you connect 3 in series, 3 in series, 3 in series, 3 in series, each 3 in series we have 120 volts. 40 amps to 120 volts. So it's going to work. If your charge controller is 195 volts, which is actually the correct specifications for most controllers, popular controllers we know. It is 195 volts. You connect 4 in series, you have 160 volts. So we have 160 volts. You can connect 160 volts, then this 10, this 10, this 10. That's not give 160 volts and 30 amps. In practical cases, you can have more than this. You can have up to 40 amps, 50 amps, 60 amps. So current is above 40, 50 amps. You need to use bigger size cables like 10 mm, 16 mm as the case may be. If you have up to 15 panels connected to a 120 amps controller, you need to make sure maybe you're connecting it 3 or 5. You need to make sure you use a cable size that is very big, large enough to carry that current to your charge controller, and from your charge controller further to your batteries. Now that is that for MPPT charge controllers. Very important, very easy. MPPT gives you more flexibility, but it makes the installation more difficult because you have to connect both in series and also you have to connect in parallel, and you need to use a lot of cables and even bigger size cables, because most times for bigger systems you'll be thinking about generating more current and also balancing the voltage, current and the voltage. So you'll be needing more size of cables, and that will cost you a lot. Then that is that for that. Then the last one we're going to talk about is the hybrid inverter. Now for a hybrid inverter, for starters, it's very, very important that you know how to use the regular controller setup, like the PWM and the MPPT charge controller. We understand the nitty-gritty of those ones, then before you can move to hybrid systems. Now for hybrid controller, this one is a little bit more technical, but still very easy. But you need to understand some basics about how to do these connections. Now, basically, you have an inverter and you have Okay, you have, let's say you have solar panels, an array of solar panels. You have the inverter and you have your battery. You don't need much. With your solar panel array, your inverter, then your battery, your home and dry. But then you need to understand what you're doing. Now, most hybrid inverters or 48-volt hybrid inverters, they have a maximum PV voltage of 500 volts. Now, as much as possible, avoid parallel connection. Avoid parallel. Avoid it. This is what has caused a lot of problems for a lot of installers out there, because they think is the normal controller setup that you have, the MPPT controller, you just do 2 series, 3 series, 4. No, avoid that. Now, for hybrid inverters that have controllers inside, they don't work with a lot of current. They work with voltage because they are actually high voltage inverters. You can have up to 500 volts. Within 500 volts, connect your system within 500 volts so the inverter to work. So the inverters need high voltage and low current to convert and give you the needed current to charge your battery. So you don't need to worry about whether you have 10 panels, you have 9 panels, and you want to connect everything in series to give you a small current and high voltage. Leave that for your inverter to do the conversion. So avoid series and parallel para-series connection. Connect everything in series. You have 9 panels, and those 9 panels, the open circuit voltage is about 45, or let's say 40. You connect everything in series, 9 panels in series. 1, 2, 3, 4, 5, 6, 7, 8. Now each of these panels, let's say we have 88, let's say it's 40 volts. 40, 40, 40, 40, 40. 8 times 4, 32, that's 320 volts. When you connect everything here in series, plus minus, plus minus, plus minus, plus minus, plus minus, then the output you just have a single cable coming to the inverter, plus and minus. So that's how you connect it. When you connect to the inverter, then the inverter will do the conversion to the required current that is needed to charge the battery based on the settings you are going to do on the inverter to make sure it doesn't exceed a particular number that you set on the inverter. So that's how to connect hybrid inverter. Very, very simple to connect, but you need to be very careful because these systems, they are high voltage systems. These panels, they are producing high voltage. High voltage DC is very dangerous. So when you expose yourself to these kind of systems, you need to make sure that you connect them with a lot of care so that you don't get electrocuted from these high voltage of solar panels. Now, so that is that for that. You need to make sure connect everything in series and make sure it is not with above the maximum voltage that the inverter can accept. So that is for that. So you want to upgrade a system, for instance, that system they are using. One thing you need to understand is before you upgrade any system, make sure you inspect the panel connection to know what the kind of connection that you did. If you are changing from PWM controller to MPPT controller, you need to go up there and observe the system to see the connections. Probably they did everything in parallel. So you need to know how many series you are going to do to make sure it matches with the MPPT. When you want to change from an MPPT to a high voltage controller, don't just connect the panels like that. When you remove the MPPT controller, you need to go up there and wire the connections to a series connection like this to make sure the inverter will work well. Don't connect your hybrid inverter to a controller that an already existing system that had a controller that did 3 series, 4 series, because when you do that, the high current is going to destroy the controller inside the inverter. So that is that for that. I hope you've been able to get 1 or 2 lessons from all I've been saying. I'm just going to end up by giving you some tips about how to connect charge controllers, what you need to know. Number 1 tip is that when you connect charge controllers, you make sure you connect the battery first before you connect the charge controllers. The battery connection has to be done. Connect the battery first, then before you connect your charge, before you connect the panels to the controller. If you connect the panels to the controller without connecting the battery, especially for controller systems, if it's a high voltage system like a high voltage inverter, there's no problem. You can connect the panels to the controller side, and those kind of systems they work without a battery. But for systems that use an external charge controller, before you connect your panels to your charge controller, you ensure that the battery connection has already been done, so that when you connect the controller reads the voltage of the battery, and then there's a communication between the panels and the controller and the battery for everything to charge properly. If that is not done, if you miss that step, you're going to destroy the controller. Then that's one. Then number two, make sure you use adequate size breakers between the panels and the controller. You don't just go and connect systems, start using a protective breaker, because it's very, very important. When you want to do maintenance, you need to switch off the breaker and do your maintenance. It's not nice for you to start removing, losing everything again because you want to do maintenance, because in the process of losing the wires from the controller, there can be a short circuit, and it's a high voltage system that's going to be very disastrous. So you need to make sure you use adequate size breakers. And then also, for controller connection, you need to understand the kind of controller you're using. You need to understand the system you're using and to know the size of cable that is needed for your connection. If you're having a lot of current, you need to make sure, let's say from a 15 amps, 40 amps and above, use 16 mm cables, 10 mm cables for your connection. Don't cut down on cable. Don't cut down on cable. If you're using a controller and the connection, the power series connection or the parallel connection indeed gives you a very high current, you need to make sure you use these size of cables. Then if it's a high voltage inverter, for instance, let's say you did 9 panels in series, you don't need this kind of cables because it's waste of material. You have 10, even if you have 9 panels or 6 panels connected in series, the current is, it should not be more than 10 amps. So when you're having 10 amps, 9 amps, it was 6 mm, you're okay for 10 amps. If you're having 8 amps for your, let's say 4 mm, you're okay. So you need to know what to use and how to use it. So I think with that, we've come to the end of today's class. So I don't know if you have any questions. If you have any questions, you can put them in the comment section. I'll be there to answer your questions. If you have contributions, put them in the comment section. I'm open to have all those things and to also see how I can improve and to give you more lessons and more tutorials like this. So please make sure you hit the subscribe button and also support my channel. Like the video, share the video to your friends, and also give me a thumbs up. So thank you very much, and I will see you again in the next video. Bye.